All right, here's the last example from our notes for section 1. And all I wanted to show you this one is I wanted to remind you, refresh you about rationalizing the numerator. So what we're going to do is we're going to use the definition of derivative to find the derivative of f of x equal to the square root of x minus 4. If you remember from a previous video, the definition of derivative is f of change of x plus x, or x plus change of x, doesn't matter, minus f of x all over change of x. And we were going to take the limit as change of x approaches 0. Okay, so I'm going to go ahead and I'm going to plug in x plus change of x, or change of x plus x, anywhere we see an x value into our original equation. So we're going to take the limit as change of x approaches 0 of the square root of change of x plus x minus 4, minus now just my original f of x, so minus the square root of x minus 4 all over change of x. And here's where in the last chapter, in chapter 1, we did what's called rationalizing the numerator, which is to say, since we really don't know what to do with these square roots and how to simplify it ourselves, we're going to multiply, we're going to manipulate a little bit, we're going to multiply by a fraction that is 1, because it's going to be the same thing. It's going to be itself over itself. And what we're going to do is we're going to multiply what's on the top. The only thing we're going to change is this sign right here. And the reason we did that because it was like multiplying, and it would make this actually then the difference of perfect squares that end up just being this term right here squared times this term minus this term right there squared. So what we're going to multiply by is the change of x plus x minus 4 plus the square root of x minus 4. We're going to do the same thing to the bottom, so that we're multiplying by 1. We're not changing the value of anything, we're just manipulating a little bit. X minus 4. So when I multiply that top, when I multiply these, it squares that first term. We're going to have a minus, so we multiply, we'll have those two minus it, or plus it, and then we'll have it minus, so they're going to end up canceling. The middle terms cancel out, and that's the nice thing about this. Just ends up being this first term here squared minus the second term squared. So all we have left over in the top is the limit change of x approaches 0 of that first term squared is going to be change of x plus x minus 4 minus then the second term squared is going to be the square root of, squared. So we're just going to have, sorry, my eraser's not working. And for the moment, my smartboard isn't, well, there we go. Sorry, my smartboard wasn't working there for a second. So we're just going to have minus x minus 4. All right, and we're still over then. We have to multiply these two values. So we're just going to keep it simple on ourselves. We're not going to distribute anything. We're just going to leave this in parentheses, the square, or change of x times the square root of change of x plus x minus 4 plus the square root of x minus 4. All right. So if you notice on the top, then we'll combine like terms. If I cross the line and change the sign, this x is going to cancel out with this x. We have a plus x and a minus x. We have a minus 4 and a plus 4. They're going to cancel out. So all we have left over on the top is we have the limit as change of x approaches 0 of change of x all over change of x times the square root change of x plus x minus 4 plus the square root of x minus 4. It's all on the bottom yet. Since it's multiplying on the bottom, since we're multiplying here, we can cancel out this change of x. And all we have left over is then there's a limit of change of x as it approaches 0 of 1 all over the square root of change of x plus x minus 4 plus the square root of x minus 4. Now we can take the limit. There's no really simplifying that we can do. We're going to take the limit, so to say we're going to plug 0 in for change of x. So we plug 0 in for change of x, and what we have left on the bottom is just the square root of x minus 4 plus the square root of x minus 4. Since the bases are the same, we can add those two. So what our derivative then is, we have 1 all over 2 times the square root of x minus 4. and that is our derivative of our function. So I just wanted to refresh us on rationalizing the numerator. We'll see you later.